All right, so this is one of my favorite sessions here, and it's a new session. This is the first time I'm teaching this session here as part of the program. And it's one of my favorite sessions because we are going to do something different. So my idea for this session is to take the training step that we created in session 4 and modify that step to run a custom Docker image to train our model. Now, why do I want to create a custom Docker image? Well, it turns out that by default, SageMaker at this point in time does not support the new Keras 3 library. And what Keras 3 is going to allow us to do is to program our model, so design our neural network, but swap the backend of that neural network to use either TensorFlow or PyTorch or JAX, which is a super new exciting library that Google has built and everyone is now using. So what I want to do, just because SageMaker does not support that, I wanted to create this custom container. And that will show you how you can train a model using anything that is not necessarily supported out of the box in AWS. So if you have your own algorithm, you have any custom process that you want to run, you can do that in SageMaker. You can create your own Docker image and you can design your process however you like, and you can bring it here, connect it to a pipeline, and the pipeline will execute that code. So in session 5, that's precisely what we're gonna do. I'm gonna create this custom Docker image, and I'm going to install JAX on that Docker image, and I'm gonna use it to train our model. Same model, but we're gonna train it using a JAX backend without changing the code. That's the beauty of Keras 3, that you write the same code, but then you can swap the backend. Okay, so here is the code of our session 5. And we are going to start preparing that Docker image. In order to do that, the first cell that you see here, let me actually close this. The first cell that you see here is me creating a folder. It's gonna be called containers. And inside containers, I'm gonna add a folder called training. And inside that folder, I'm going to be copying the same script that we created before. Remember that we created the training script in the past session. I'm going to be copying this same script into this containers/training folder. So I'm going to do that. And if I go, after running that code, if you go to that folder, this is the folder here, you're going to see that training script right there. I'm renaming the file using shutil. As I copy the file, I'm renaming it to call it train.py. So it's clear that that's the training script. I'm gonna open that script. This is the same script that we created in the previous session. The beauty of this is that because I'm using Keras, all of this code is compatible now with what I'm going to do, right? I didn't use anything specific of Keras 2. So all of this code is gonna be compatible. As a reminder, we created this at the time of saving the file. Remember that we did this, I don't find it right now, but we asked at some point, oh, here it is. We asked about the version of Keras in order to save the file using one format or the new format. And my goal was to just have one script compatible with Keras 2 and Keras 3. So this is our script. I'm copying that script inside the containers folder. You see more files here because I already ran my pipeline. I'm gonna be creating those files now. We're gonna work through that. The next line here is I'm creating a requirements.txt file with every library that I want to install in that custom Docker container. Remember, I need to design a new image from scratch. I'm gonna be creating a new Docker image to run the training process because the SageMaker images, the out-of-the-box images, they do not support Keras 3. They do not have at this point in time any images with Keras 3 installed in them. So I'm creating a new blank image from scratch. This is the list of requirements that I'm gonna be asking SageMaker to install in my Docker image. Actually, Docker is gonna do this, not SageMaker. Yeah, let's see what I have here. This is the most important one. It's called the SageMaker training image. And you do that to ensure that your container is going to be compatible with SageMaker training processes, okay? So whenever you want to create a SageMaker custom image for training, you need to install the SageMaker training package. That's gonna make that image compatible. It's gonna install all of the libraries. It's gonna install everything that you need to run this container as a training process. All of the other libraries are there, including Keras. The other one that I want to attract your attention to is JAX. I'm installing the CPU version of JAX. I'm not running this on a GPU. This is what's gonna let us run our model with a JAX backend. Notice that I'm not installing TensorFlow at all. So this is gonna be my same model, the same model that we created and we trained using TensorFlow. Now we're gonna be using JAX to compile that model. If I wanted to use PyTorch, well, I just need to install PyTorch in this container and tell Keras to use PyTorch instead without changing a single line of code. That is beautiful. That is what multi-framework machine learning looks like, okay? So it's beautiful. All right, so I'm gonna create this file, and the next cell is defining or creating the Docker file. It's just the definition of what the Docker container will look like. And again, I'm just using the same technique. I'm creating the file within that folder. You can see that I'm starting from a Python 3.10 base image. When you create Docker files, I don't know how familiar you are with Docker, but when you create an image, you can start from a base image. So you can inherit everything that's already installed on the base image, and then you can add to it. That's what I'm doing here. I'm starting from a Python 3.10 Slim image, and you can find all of those images if you go to Docker Hub, for example. Let's go to Docker Hub. So if you go to Docker Hub, you can find any image you want. So if I look for Python, let's see. Here you see all of the tags, and you can start your image from any of these tags. I started from 3.10, but again, if I wanted like a PyTorch image, you could come here. Let's see the tags. You could start from the latest. You could start from 2.2.1, CUDA 12.1, whatever, right? So you can pick an image that you want as a base, and from there on out, you can add your own stuff. All right, so let's go back to the code. This here is gonna run this. So when we start creating this image, we're gonna install all of these Linux libraries. Remember, this is just gonna be a Linux-based image. It's gonna install all of these libraries that we need in the container to run the stuff that we're gonna be doing. I'm gonna be copying the requirements file that I just created. So I'm copying that file from the folder into the image. That's what's happening in this line 14 here, right? Copy requirements.txt. Remember, I already created that file, not here. Here it is. This file, I'm copying it from the local folder into the image, and then I'm upgrading PIP and installing all of those libraries. So when I'm creating the image, I'm gonna get all of the libraries that I specified before installed in that container. Then I'm copying the train.py file. Remember that we created that file right here. I'm gonna copy that file into the image as well, into a specific folder. This is the folder where I'm copying that file. Then I'm setting an environment variable that's called SageMaker program, and I'm setting that environment variable to train.py. What's going to happen is that by default, remember, we installed the SageMaker Python library in this Docker container. It's part of our requirements.txt file. So internally, the process that SageMaker is going to run, that library, thanks to that library, is going to look up for this environment variable, and it's going to execute automatically when we run this container. It will automatically execute this file. So that means I don't even need to specify the file when I'm configuring the SageMaker step, because it's going to run automatically. I'm just running automatically that train file. And finally, I'm creating a new environment variable, which is Keras backend. And I'm specifying that I want JAX. If I wanted to run PyTorch, I could specify that this is gonna be the Torch backend. If I wanted to run TensorFlow, I could specify that this is a TensorFlow backend. And just by changing this environment variable, that's it. My entire network now is going to run using a different backend, which is amazing. Okay, so I create this Docker file, and now it's time to build the image. So in this cell right here, what I'm going to do, and I'm not going to explain line by line, but basically what's going to happen is I'm going to use the Docker application to build my image. That's the first thing that I need to do. Now, let's see what's happening. This is the image name. I'm going to call it Keras Custom Training Container. And then I'm going to ask if we are not running in local mode, meaning we're ready to run this in the cloud, then I'm going to print building Docker image for Linux AMD 64 architecture, and I'm going to run the Docker command. Remember that Jupyter gives us the ability to combine in the same cell Python code with bash scripts. And this hashband character indicates that this is a bash command. So it's going to get executed on a shell. So this is like just opening a terminal and running that command. That's what's happening here. Let's look at the command. It's Docker build. Then I'm specifying a platform. And this is crucial. This is really important because here I'm running on an ARM64 architecture. I have an Apple Silicon here. If I build my image on my computer, what is going to happen is that I'm going to create an image that is not going to be compatible with a Linux computer or an AMD computer, not a Linux. Linux is the operating system. It's not going to be compatible with a PC, with an x86 or an AMD 64 architecture, because all of the libraries are going to get downloaded and compiled for ARM64, which is the one that I have here. So I need to make sure I tell Docker to build this image for Linux AMD 64. That is why I specified that platform there. Now, obviously, that image will not run on my computer. Like if I try to execute this image in my computer, it's not gonna run. That is why I'm asking if we are not running in local mode. Because if we are running in local mode, I'm just gonna create the image using my platform, using whatever I have on my computer. Because if I'm running in local mode, I want to execute that image on my computer. I'm gonna be testing that image on my computer. But if I am not, if this image is gonna run in the cloud, I need to make sure it runs on AMD 64. Hopefully that is clear. So Docker build, I specify the platform, then I specify a tag. So how am I gonna call this platform? So the tag is gonna be the image name. You see this $sign? This is how I get a variable that's in Python, and I use that variable in my bash command. This is just beautiful, by the way. This is just thanks to Jupyter. This is just amazing that you can do that type of stuff. So I'm using a variable that I defined in Python as part of a bash command. That's just amazing. All right, and then I specify the location of where the Docker file is, which is in this location here that we created. So this command is just gonna build our Docker image. Now, if we're not running in local mode, if we are running in local mode, I should sort of like reverse this so I don't have a negative condition here. So if we are running in local mode, then I'm gonna do the same thing. It's just I'm not gonna specify the platform. I'm not gonna fix it to a platform. I'm gonna let Docker select the platform based on what I'm running on my computer. Fair warning, this command will take some time to run, okay? So the first time you run this command, it's going to take some time because it has to build the Docker image. It has to first download this Docker image to your computer. So it has to download a Python 3.10 Slim Docker image. It's going to take some time to download that. And then it has to build this new image. And building the image takes time. You have to run a bunch of libraries. You have to install a bunch of stuff. So it's going to take some time to finish the first time. After you do it once, obviously it's going to go way faster. You can see here, I'm not going to run it right now, but you can see here when I run it, all of the commands, the output of the Docker command, this is just how it's building the image. It goes on and on and on and on and on, building that image. So it's going to take some time to finish. After we're done, after I finished with that, the next step is for me to make this image available for SageMaker because I built the image locally. It's right here on my computer. So now I need to put it somewhere online so SageMaker can use it. at the time of executing the training job. Like if I want to test this locally, okay, that's awesome. But if I want to run this in the cloud, I have to put that image, make it available to SageMaker. So how do we do that? Well, SageMaker supports, or they have a service called Amazon Elastic Container Registry, not SageMaker. This is an AWS service. I apologize. It's an AWS service called Elastic Container Registry, or ECR. So let's take a look at that service here really quick. All right, so let's go to ECR, and this is the Elastic Container Registry. So I'm going to open that in a new tab, and here we are. I already have a repo there, which is the one that I created for this image, but this is pretty much what you're going to see. This is like Docker Hub, but private for your AWS account. Here you can put any Docker images, you can maintain them. If I go inside, you can see the tags that I have. I have a couple of tags because I configured this repo to delete all tags. And actually I have an assignment that it's going to ask you to do the same, to investigate how to do the same. So you don't have like many tags that are not used. I only keep the latest couple tags. Okay, cool, awesome. So this is ECR. So let's see how we push something to ECR, because that's what I need to do right now. So this whole cell is going to be bash. That's how, this is how you do it. I specify that everything that I'm gonna run in this cell is just bash commands. Now look at this. I'm gonna pass a couple of variables, and those variables are coming from Python. So you pass the variables like this. I pass the local mode, and I'm gonna pass the image name. So I need inside to know whether we're running in local mode, and I need the image name, which is the one that I'm going to upload to ECR. Algorithm name is the second variable. So starting from now on, instead of using $2, which is image name, I'm just gonna use algorithm name. Account is going to be the result of this command. And again, you can, if you want to try this out, you can copy a command. You can go to your terminal. Let me just clear this, and you can paste that command. And this is gonna tell you what's happening here. Like if you wanted to run that, this is returning the ID of my account, my AWS account. That's what that command returns here. So that I'm assigning to account variable. Then I configure the region. And again, my region is US is 1. Let's run this again, just so it's just clear. US is 1, that's what's returning. I'm configuring the region here. And if region is null, if it's none, if it's not configured, I'm going to assume is US is East 1. This is going to create the name of the repository that I'm going to upload. When you go to ECR, you need to create a repo name that later on, that's what you're going to specify to download that image. The repo name is going to be the number of my account, DKR ECR. That's just the URL that Amazon expects you to use when you access ECR. Actually, if you guys remember, let me go to SageMaker here really quick, because I want to show you something that later on is going to become very important. So let me open my studio. Let's just open a studio here. Let's go back in studio to the pipelines that we ran yesterday. Yesterday we ran session 4. Here is the pipeline, and here is the train model. Let's click on that train model. Let's go to settings. And I want you to look at this. This right here is the algorithm that we used yesterday to train our model. Pretty much is the Docker image and the location of that Docker image. So I'm gonna copy this. I'm gonna paste it here so you see it a little bit better, because I want you to see all of the parts here. This number here is the AWS account that is hosting this ECR repo, or the repository. This is just an Amazon owned account. That is the same thing that I'm adding here, this account. Then it comes DKR ECR, which I'm adding right here. Then it comes the region, and you see the region US is 1. In my case, that's the TensorFlow image that I was using yesterday. I have the region right here. Then it comes AmazonAWS.com/AmazonAWS.com/. Then it comes the algorithm name. And yesterday we were using the out-of-the-box TensorFlow image to train our model. That's why you get TensorFlow training, version 2.12, CPU, we're not using GPU, Python 3.10. That's the name of the repo. The name of our repo is going to be algorithm name, which in our case, it's the Keras custom whatever. And then the tag that we're going to use, the tag that we're using in our training algorithm out of the box is 2.12 CPU Python 310. The tag that we're going to use is called latest. Anytime you push to one of these Docker repos, the latest version will automatically get tagged as latest. Great, awesome. So we have that. That's the name where we are going to store this thing. And now I'm gonna be asking if local mode $1 refers to local mode is false. So we only want to push, obviously, the Docker image if we are not running in local mode. If we're running in local mode, we don't need to push that Docker image anywhere. But if we are not, then we need to push the Docker image. So here we're gonna do a describe repositories. See it doesn't exist, then we're gonna create that repository. So we're gonna check in ECR, hey, is there a repo with the name of algorithm name? And if there is one, we're not gonna do anything. But if there isn't one, then let's create that repo. And again, this is just bash. That's the language that you see here. That's why it's a little bit ugly. All right, so after doing that, now we can just log in. You need a login and password in order to access that repo. So this is how I get that sort of like authentication. And then I can do a tag. I can take the image. This is the image that is running in my computer. I mean, not running, it's saved in my computer. And then I'm gonna tag it. By tagging it, I mean you add sort of like you name it before you push it. So it goes with that name. So I'm gonna tag that image with the name of the repository where I'm gonna be uploading it. And then I'm just gonna push it to that repository. And this Docker push, this is the command that's gonna just upload that image to my repo. So when you execute this line, assuming you are not in local mode, this is what you should see, right? It starts pushing all of the layers, like Docker images, they have multiple layers, and it starts pushing all of the layers that don't exist. And at the end, you should get something like this: latest digest, and the SHA 256 size, blah, blah, blah. So you should get something like this. This tells me that my Docker image is now up there. I can now use it in the cloud because I have it stored in my AWS account. So how do we use it now? We already have what we need. We just need to configure our training step to use this image. Here is, let's see how we configure that. First, I have a cell here. And this cell is just gonna compute the name of the Docker image. That's it. So depending on if you're in local mode or not, I'm just gonna use one name or the other. So in this case, I should not be in local mode. Oh, actually, I need to run all of this. Let me just run the notebook. I should have run this before starting the video, but anyway. So this cell here, let's see what it does. So I'm just gonna get the account. I'm gonna set up the tag, which is the latest. I'm going to just pretty much prepare the name where this is gonna get stored. And I'm gonna say, hey, training container image is going to be the image name if we're running in local mode, just the name. But if we are not running in local mode, then just create that whole URL, right? That we did before in Bash, we're doing it here in Python. Just create that whole URL again. Okay, awesome. So cool. So in this case, we are not running in local mode. So as you can see, this is the name. It's pointing to my ECR account. If we were running in local mode, let me just cheat here for a second. Let's say local mode true. This is just to see this cell rerunning. You will see that we will be getting Keras custom training container. Let me set this back to what it was. Cool, awesome. So I'm gonna set that back and I'm gonna re-execute this. Alrighty. So now is the time to configure that training step. As a reminder, a training step requires an estimator, and the estimator is the one that's going to specify what image is going to use, the version, all of that good stuff. Before, in session 4, if we go to how we define the estimator in session 4, this is what we have. We used a TensorFlow estimator. And remember that I told you that SageMaker provided out-of-the-box classes or estimators that behind the scenes, they defined already what was the container, the image you were going to use if you were using those estimators. Now we have a custom one. So we cannot use an out-of-the-box estimator. We're just gonna use the base estimator class, right? So if I go back here, session 5. I'm going to be using just the base estimator class. I'm going to be specifying what is the image. You can see it here, image URI that I'm going to be using. And in this case, it's just the name that we computed, this long name here, in case I'm running this in the cloud. How many instances? Just one instance. What is the instance type? I'm going to use the ML-M5 XLarge. And what is the session, which is going to be the pipeline session. We already saw that before. And the role, obviously. So, we give permissions to this estimator. And finally, after creating the estimator, I can just call the function that I defined before, that is create training step, and specify my new Keras estimator to create that training step. Let's just go and see this function here for a second. Just as a quick reminder, this is just creating a training step where we use the estimator here that's supplied, and we specify the inputs, and all of these inputs, they're gonna be turned into channels. So I'm passing the train set coming from the previous step. I'm passing the validation set coming from the previous step, and I'm passing the pipeline that's also coming from the previous step. And here is how I'd reference that previous step, the output of the previous step. We already did this. We set the cache configuration for this step. That's pretty much it. After creating this step, now we can define our pipeline, session 5 pipeline, and the pipeline is gonna have the pre-processing step, which is the one that we defined in session 3, and the new training step, which is the Keras training model step. And this new training step, this one is custom now. So the algorithm that's going to run is a custom algorithm. Let me see what else. Here we observed that pipeline, and that's it. Now let me show you a couple of things. First, I'm going to run this locally so we can try it out. Let's go to local mode. Where do I define that? Here it is. I'm gonna set this to true. Okay, so I'm gonna define that true. I'm going to run everything up to this point, and then I'm gonna execute this pipeline. Just make sure it runs locally. And something that you are going to notice is that, remember that we were printing as part of the training script, we were printing the Keras version. And I don't know if you remember, but in the last session, we were using 2.12. That was the Keras version because it's tied to TensorFlow. In this new session, when we run it, we should be seeing Keras 3 point something, because now we're installing the latest version of Keras, and we're using a JAX backend to run everything here. That should be a difference that we should see when we run session 5 pipeline. Well, while that runs, let's go here and let me show you session 5 here. And this I ran yesterday, and so we don't have to wait for this to run. But let's look at the train step. This is different from the pipeline that we saw in session 4, because remember that pipeline used the out-of-the-box training step. But this one here, if we go to settings, you will see that this train model, this is using our Keras custom training container. So that is the difference. Let me show you something else. If I go to details, you're gonna see the logs here, right? You see a list of logs attached to this step. Let's open the logs in a different tab and let's explore those logs, okay? So this is the log stream that the training job generated. And let's go up, and you will see when we started the script, here it is. We are using Keras version 3.1.1. That is the new version of Keras that allows us to use a different backend. You can see all of the logs here. By the way, you can do this on every single step of a pipeline. You can just review all of the logs. You can see all of the logs up there. Let me see here our environment variables if we get something about Keras. I don't know if we're gonna get something about Keras here. I'm gonna look it up. Keras, that's it. I think that's all that we get. Yeah, that's all that we get. Okay, all right. So there are no more logs about Keras. Let me get back here, run this finished executing my pipeline, not executing, but running my cells. We are ready to test session 5 pipeline. Let's go here, change the name of the pipeline that I want to execute that pipeline. What's going to happen now, assuming that this works, is that my pipeline is going to use the local image that we created, the custom Keras image. So it's going to train my model using that custom Keras image. All right, so a bunch of stuff happening here. Here is Keras version 3.1.1 as well, running on locally on my computer, which is beautiful. Here is me training the model. Aborting container, stopping, stop, train model, successful. So that worked as well. So what we did here was just running a pipeline using a custom training container. And you can do that not only for the training job, you can do that pretty much for any step that runs a container. You can bring your own container and you can do whatever you want inside that container. The other thing that I want you to take away from this video is the ability to write your code once. If you use Keras, the new version of Keras, you write your code once, and then you can swap whatever backend you want. If you want to compile your model and run your model using Torch, you use Torch. If you want to use JAX, you use JAX. If you want to use TensorFlow, you use TensorFlow. By a single line, with a single change, you can swap the backend of your model. The power of that is not only that it's a common language that people don't have to fight, is TensorFlow better than Torch anymore, but it also allows you to use the backend that's better suited to your problem. So different models are going to be faster in Torch. Other models are going to be faster in JAX. So if you, or TensorFlow, if you have the ability to just swap the backend, now you can use the best for your particular problem, which is great. All right, so with that being said, all of this is running. This is great. I'll see you in the next one.